Good afternoon to all. This is the P. Janagaratnam from Department of Mechanical Engineering, SNS College of Technology. In my previous video, I already discussed about the heat transfer problem 1 considering the two elements. In this problem, we are having the three layers. A furnace is made up of three layers: inside layer with the thermal conductivity, and middle layer with the thermal conductivity, and outer layer with the thermal conductivity, and respective thickness value also given. And the inside temperature, which means the starting temperature is 600 degrees Celsius, and the outside of the wall is exposed to the atmospheric air at 32 degrees Celsius with heat transfer coefficient 45 Weber per meter squared Kelvin. Determine the nodal temperatures. In our previous problems, we are having the two elements, so we are calculating the nodal temperatures T1, T2, T3. Here we are having the three elements, so number of nodes will be equal to 4. 1, 2, 3, 4. So totally we are having the 4 nodal displacements. So first I can write down the given data K1, K2, K3, L1, L2, L3, and T1, T infinity, H and R. We can find out the nodal temperatures T1, T2, and T3. So next, first we have to find out the finite element equation for the element 1, which will be only we have to consider the conduction. So normally we can use this relation. We have to find out the finite element equation for the element 1. After that we have to calculate the finite element equation for the element 2. Again the element 2 also only having the conduction, there is no convection. So again we have to use this same equation for the finite element equation. So we can find out the second finite element equation for the second element. After that, third element is subjected to both conduction and convection. So the finite element equation which will be having the conduction and convection, so we can use that relation, like we can use that H T infinity A. So we can find out the third finite element equation. So assemble these three finite element equations, we will get the assembled finite equations. We will get, in our previous problem we will get the 3 cross 3 matrix. Here we are getting the 4 cross 4 matrix. So K is equal to T into F. We can substitute the known forces value F1, F2, F3 values equal to 0. Only we are having the F4 value 13.635 into 10 to the power 3. So this is the final assembly equations. We can follow certain steps to solve the heat transfer problem for solving the nodal temperature. So the first step, we can convert the first column of the stiffness matrix has been set equal to 0 except for the main diagonal value. This is the main diagonal value. Except this main diagonal value, we can set all the row value and column value which will be equal to 0. The second the first row of the force matrix is replaced by the known temperature at node 1. We are already known the temperature at node 1 value is equal to 873. So we can replace the first force matrix value which will be equal to 873. After that we can multiply the first row and second, then third one is we can multiply the second row and first column, which means minus 34 into known temperature value which will be equal to 873. We will get minus 29632. This value will be replaced by the second force matrix 29682. So finally we can use the Gaussian elimination method. We can convert the lower diagonal matrix will be equal to 0. Again, so using some relations, we can by using Gaussian elimination method, we can convert the lower triangular matrix which will be equal to 0. After that, directly we can find out the 46.665 T4 is equal to 15.079 into 10 to the power 3. So easily we will get the T4 value. The second equation will be T2 minus 0.379 T3 is equal to some values. and next equation is T2 minus T3 values equal to 0. We can solve these two equations. We will get the temperature value like T2 is equal to 846 and T3 value is equal to 664.11 Kelvin and T4 value is equal to 323 Kelvin. So initially we are having the conduction, after that it will be gradually decreased to the convection. So 873 will be gradually decreased to 323 Kelvin. This is the general heat transfer solution. This is the general verification process we have to follow. We will get the same values. Thank you. Next class we had to discuss about the isoparametric formulation and Gaussian quadrature problem. Thank you, Ananda.